Our first speaker is Dr. Rajesh Valte, keynote speaker for the day. He leads Innovation and Technology Center at Veolia, Bangalore, focusing on R&D in water and wastewater treatment. Today, he will speak on innovative flowsheet for textile wastewater treatment, turning textile waste to resource. Over to you, Dr. Valte. Please.
Good morning. Good morning, all of you. Thanks for this opportunity. So to begin up with this session, before we go into that, little bit introduction about me. I have done my MTech and PhD in Bioprocess Technology from ICT Mumbai, and I come around with 15 years plus experience into membrane separation technologies, water wastewater treatment technologies. Today, I am leading our R&D team at Veolia, which is based at Hoskote, Bangalore, where we are part of global R&D organization of Veolia. We support local projects of South Asia, as well as we are part of global R&D team where we work on innovation. So thanks Gartex and DL AI for giving this opportunity. So we take this opportunity to bring up an innovation, one in the field of textile wastewater treatment that will result in recovery of one product or resource other than water. And our team has been working on this flow sheet since last 1.5 years. We have filed a patent around this. So what we're saying is an innovative flow sheet, turning your textile waste to resource. Before that, let us understand a little bit about Veolia global presence. We have around 218,000 employees worldwide. We are based in around 58 countries, and this is world's largest company in terms of water, waste, and energy with a revenue of $45 million. What we do, our core business are into 4 areas: technology and products. You will meet my colleagues Sandeep, Sujata, and people around here at our stall H35. We have a display of our technology products, what we bring up in the textile market. Next is we also do engineering, procurement, and projects. So not only selling products through OEM, where OEM will build the plant, but we building end-to-end solution and taking process guarantees for deliverables, whatever they are in the projects. And integrated services, O&Ms and BOO models. Little bit about South Asia. Globally, we are there, 218,000 people in South Asia, 2,000 plus people. We have a world-class engineering center. To give a highlight that, 60% of Veolia's engineering happens in South Asia, giving back huge $1 million to business. We have a manufacturing plant in Hoskote where the technology center where I come from is based, along with the rolling of the membrane facilities and blending of chemicals. Okay, now jumping down to the topic. So textile market globally, if you look at the textile market globally, it's around the export of textile products is $950 billion. Now, if you look at this export, APAC contributes to major around 47%, roughly $450 billion. In the APAC, you will see the countries like China being at the topmost, the exporter around 32%, and Bangladesh, Vietnam, and India together around 15%. So this is the scenario. Now coming down to India, being a 4th largest exporter, contributing to around $41 billion. When it comes to dyeing industries, we see in India, people are using 2 types of salts. Either it is sodium sulfate or sodium chloride. These are used for fixing dye to the fabrics. And all of these industries generates huge amount of effluent based on the region. Like if you go to Tirupur market, water consumption is low. The CETPs run at 8,000-10,000 TDS. If you go to Ludhiana market, the TDS are low. You see India market, the TDS of effluents will vary in the range of 3,000 to 12,000. As we all know, India water crisis exists. So recovering water and even innovating technologies where you can effectively recover water, optimize the capex OpEx is a key driver. Today, if you see in India, you'll see there are 2 types of approaches. People are going for ZLD. You'll see ZLD plants. Some people are not going for ZLD. And yes, understanding the water crisis in future, the pressure and recovery target, the regulatory bodies are going to push for more and more water recovery. Important line is if you see at the bottom, dyeing is the second largest cause of global water pollution. After sewage and municipal, see, each kgs of fabric consumes huge amount of water. And that's why, when this fashion goes on increasing, the effluent generation by all these industries are huge. You talk about 5, 10, 15, 20 MLDs. So there is a scope of innovation there, that how would you intensify the process? How would you improve the process? Now we understand little bit of the source used in dyeing. Let us understand that why sodium sulfate is used by different industries for dyeing process, and how it is better over sodium chloride. Okay, so basically all these fabric, cellulose fabric, cotton derived cellulose fabric are negative in charge, and the dyes, mainly reactive dyes used, are also negative in charge. Now when you have a negative attraction, or when you're trying to fix a charge, there will be a repulsion, obviously, right? So what it means, you need to minimize this repulsion, and for the dyes to fix to the fabric. But there are several advantages of using sodium sulfate versus sodium chloride. Ionic charge, the positivity is more in terms of sodium sulfate. Second is bonding strength is better. Third is exhaustion rate is slower compared to sodium chloride. And lastly, you'll get more uniform distribution of the dye when you use sodium sulfate. Now, what we thought of playing around this driver, okay, today, even though people are using sodium chloride, suppose you have a technology where you can recover sodium sulfate from your effluent, make this textile waste to resource, and if you can reuse back, that may allow in future people to shift to sodium sulfate. Because today, price is the game. Okay, sodium chloride is cheaper, but if I can recover 70, 80, 90% of sodium sulfate from my effluent and reuse, that will be a driver. Now, this is an important slide where I will be throwing light on what innovation we did is. So, bundling Veolia technology, we have several products in a typical wastewater treatment flow sheet. What we tried to do in R&D, we thought of an idea for which we filed a patent. Okay, the textile effluent, if you see and analyze, either it is a Bangladesh, APAC market or India market, people who are either using sodium sulfate or sodium chloride, these components will contribute to 75 to 80% of the TDS of the effluent. Now, I am trying to think of an idea. I convert this effluent into the product and I purify this to a substantial level where I can reuse sodium sulfate. So the technology what we developed is we try to remove more than 90% of organics, monovalent and hardness from this effluent, generate a substantially pure sodium sulfate stream which can be directly used back in dyeing. Okay, there are several plants, like adiabatic chilling is one of the technologies by which you will get a powdered 99% pure sodium sulfate. But chilling, capex and opex thermal solutions around adiabatic chilling is very expensive. What we are trying to say is, with minimal spending in terms of energy, capex and opex, if I can convert my liquid effluent to a liquid sodium sulfate stream, which is reused back in dyeing, it will make a differentiator. Now, what are the drivers? If you look at this, reusing this in the liquid form without evaporating, crystallizing, or without using expensive tools like adiabatic chilling, this is going to save 25 to 30% of capex and opex. Okay, what is going to happen is now how? Okay, today when we compare with the people running conventional ZLD, my all effluent goes into the ZLD, multi-stage RO, UFRO and ZLD. Now, if I imagine a case, if I am recovering 75-80% of that as a product in the liquid form, my load of ZLD has reduced. My solid disposal has reduced. This saves a substantial capex and opex of around 25 to 30%. And additionally, this flow sheet or this technology, when we are desizing the ZLD, the ZLD output, finally, the evaporator output, crystallizer output, the waste disposal, that goes into the landfill. Now, when I'm converting the 70% of waste as a product, I am also minimizing my waste generated in the. Now, this also is environmental friendly because it helps in reducing CO2 emission and contributing to lower carbon footprints. How? See, consider an example of typical 5-6 MLD textile effluent plant. you are typically using 7,000 to 8,000 tons of sodium sulfate each year, for dyeing. Now, if this technology, what we have worked in the lab and probably works in piloting, consider a case if I am not needing 7 or 8,000 tons of sodium sulfate each year, I am saving logistic, I am saving the chemical cost for buying this product. This is how it contributes to lowering the carbon footprints. And yes, obviously, the approach will help in circular economy and promoting sustainable solutions. Now, what we try to do around this is develop technologies to solve this problem in two fronts. One is remove the color after biological treatment. See, every textile industries will have color because of dyes, and whatever compounds, organic, inorganics, which are used in the pre-treatment process, fabric processing process, that will contribute to organics, right? So remove the organics, remove the color, use the membrane, enrich the sodium sulfate, and also in the downstream of membrane, we soften this water stream by removing hardness. So basically 3 targets, okay? Our objective was to meet 3 things, 3 goals. We remove 90% of organics, we remove 95% of color, and we remove 95% of hardness. Meeting this quality of green box, you see, 60 GPL sodium sulfate, less than 100 ppm hardness after we remove more than 95% of hardness, and color just few ppm, and COD less than 1000 ppm. Now, when we look at the color removal technologies, okay, now color removal technologies, there are different technologies we try to explore after a biological treatment to remove the color. Like ozone, if you look at ozone, you need around 150 ppm of dosage of ozone to reduce the color from 1000 to 1200 PTCO to less than 200 or 250 PTCO. What does ozone does? It breaks the conjugated bonds of a chromophoric molecule in dyes which are responsible for color. That is how it is a greener technology, it will remove the color. Now all these dyes are anionic in nature. Another technology is using cationic polymer. So cationic polymer with this anionic dyes will form a flock which will settle. That is also one of the technologies, but that needs high OPEX. You see the OPEX of cationic polymer is 2 times higher versus ozone. Now you can always optimize the OPEX by blending 2 technologies such as ozone and cationic polymer. And finally, what we feel is ozone is more lucrative solution. The reason it is a cleaner solution and the OPEX is less. To intensify the ozone process, if you integrate boosters such as sodium hypochlorite or hydrogen peroxide, that will take care of removing color to say 25-30%. You are desizing the ozone system and saving substantial capex and OPEX. Now, this slide shows the comparison of OPEX, based on lab developed processes. If we try to mimic to a commercial scale, what are the technologies available to remove color in the upstream after biological treatment? I would recommend ozone as one of the option. Cationic polymer. Now, if I say that, in cationic polymer, I don't need capex because the capex is there, ozone and needs more capex. But if you look at the saving of 30 to 45 rupees per cubic meter by ozone, because ozone OPEX is 25 rupees per cubic meter to reduce a color of 1000 to less than 200 PTCO. With polymer cost is 2 times higher. Now this saving will give me payback of ozone system in just 1.5 or 2 years. Initially you may feel capex is high, but this is why it is important. Now what happens when we have removed the color in the upstream, okay, and then we use nanofiltration to concentrate the sodium sulfate and enrich it. At the downstream, we need to understand that although I have achieved something like this lighter color, it is going to enrich in NF reject because I am concentrating by 20 times. So there also we evaluated the technologies to remove the color, where we also find that ozone could be a lucrative solution after softening. Now coming to membrane, nanofiltration membrane to concentrate and purify sodium sulfate, we have our products such as DL, Durasleek, SWSR type of membrane, which has ability to retain more than 98% of sodium sulfate from the effluent, concentrate it to the 60 GPL concentration, what we need for dyeing, This is a proprietary membrane with 3-layer chemistry. It's a polypiperazzinamide chemistry which has got lower fouling and better flux. So this is the product what we are trying to promote for cases where we are trying to look for, sodium sulfate stream, where we want to concentrate to a level what is needed for dyeing and also purify it by removing monovalent. See, NF is going to concentrate sodium sulfate, retain it, but remove all the sodium chloride and monovalent salts. So it is going to purify that stream also. Finally, the stream what we are trying to dye, it also has a limit of hardness. When typically the effluent will have a hardness of say 50 or 100 ppm, that is going to go to 1500 or 2000 ppm. So softening is needed so that the hardness culprit doesn't affect the dyeing process. So we have developed a process for that, which is not a conventional lime soda softening, but it is a alkali NaOH treatment which can remove more than 95% of hardness. Now finally, these are the results. If you see the process stream what we developed after integrating these different technologies, when used for dyeing, it gives you similar results like using fresh or market highly pure sodium sulfate. When we reach 60 GPL sodium sulfate concentration for a substantially purified stream, which is needed for darker shade, it can be diluted to 40 and 20 GPL for a medium and lighter shade, and it works for all these dyes. How do you check that the dyeing is efficient? There's a term called delta E value. So delta E value is a UV spectrophotometric method which gives you the idea that dyeing has been effective, it is uniform, it has dispersed well, and the process stream what we developed in our lab has successfully made the delta E value of less than 1. If you see all this fabric, it's in a range of 0.2 to 0.4, and standard says it has to be less than 1. So that is a key breakthrough, I would say, of this R&D development. Now, finally, let us look at one business case. Okay, I'm trying to compare. Having said that, we have integrated different our Veolia products and converted this textile wastewater to substantially pure sodium sulfate stream. How do we compare this with conventional ZLD? Okay, now consider a case of a high TDS effluent, say 8000 ppm, where 60% around 5000 ppm is sodium sulfate. You have color, you have hardness, and you're going with typical ZLD. I'll not go into details. So what I'm trying to bring here, audience, is, now what we are trying to say is this is our patented innovative flow sheet. If we integrate, if you see these green boxes, so MBR technology for COD removal, followed by ozone and hypo for color removal, followed by NF for concentrating, purifying sodium sulfate, followed by clarifier for softening, and then again ozone for removing color, we generate a substantially pure sodium sulfate stream which is reused as such in the liquid form. Now doing that, what is happening is my 8000 TDS which was going to ZLD, it doesn't go, because now my size of ZLD goes down by 50-60%, because whatever is the NF format which comes out here, it is a lean stream, colorless stream, gives you better life for RO, and you're desizing ZLD. Now this is an important point here, okay, because I am not loading 8000 TDS to the ZLD, but I am loading 3000 TDS to the ZLD. I am desizing ZLD of a conventional textile effluent treatment plant to half or 2.5 times. Plus, I have recovered and reused 60, 70, 80% of sodium sulfate. So my sludge generation is less. Sludge generation, you all know, contributes to 25 to 30% of OPEX of ZLD. 6,000, 7,000 tons rupees, 6,000, 7,000 rupees per ton is a huge cost. Now, if I convert it into the products, my sludge handling and sludge disposal cost goes down. Plus, I am recovering water. Now, if you look at the economics, I just try to put some ballpark number. This is an interesting slide, okay? Now, when you compare a conventional ZLD approach with this new innovative flow sheet, if you compare in terms of OPEX, you will see instead of 200 or 250 rupees a typical ZLD OPEX, it is less than 150 rupees, and this saving is around, for say 6 MLD plants, is 12 crores of saving of OPEX each year, which is around $1.5 million per year. In terms of capex, if we look at a Veolia capex for a typical ZLD, it is for such 6 MLD plant, which is $12.7 million, it comes to less than $10 million. So point I'm trying to bring there is, if this innovation is successful in piloting and flies up ahead, we will have a substantial saving for textile wastewater treatment, converting waste not into water but also a product, reusing back and giving more offerings to customers. Now, lastly, where are we? So we have developed this process in our lab since last 1.5 year. We have filed a patent. We are talking, Sandeep from our sales leading is here. We are talking to our OEMs, different people, to find out where we can pilot and explore this in long-term run. And then we are happy to sell our products in this Flowsheet or do projects in future. Okay. Now, lastly, just a couple of slides touching based on Veolia products. So we saw in the textile flow sheet itself, what I explained, there are several Veolia products will come into the picture. You can visit our stall and discuss in more detail. However, apart from that, for the audience or anybody here who want to understand what products we have in textiles when it comes to water, wastewater treatment, I have just listed few of these products. ZVD MBR that will remove COD, turbidity, TSS, and particulate coloring stuffs will be removed. Yes, we have 40 plus references in Bangladesh for our MBR installations, running at typical capacities of 5 or 6 MLD. Then we have another product called as PUF, which is a pressurized UF. So, basic chemistry of ZVD MBR, PVDF membranes remains the same. These are submerged, these are on skid, PUF membranes. They also play a similar role, to remove the colloidal COD, turbidity, TSS, and when it comes to conventional biological treatment plant, like activated sludge process, you can always integrate our PUF after that if you want to go for the downstream processing. Another interesting product is nanofiltration. Okay, so nanofiltration, we have two products, DuraSlick membrane and SWSR. So as I told you, okay, in the flow sheet, what I explained, patented flow sheet, you can use nanofiltration to concentrate sodium sulfate, enrich sodium sulfate, remove the monovalent. Okay, there are also another applications where you can use our NF to remove the hardness, because NF are the products, they are going to retain hardness and they are going to permeate monovalence. So that's one of the application. Third thing, which is not here, the color removal. A lot of people are also using nanofiltration for color removal. Our objective in this patented technology is to use NF for enriching sodium sulfate and remove color by other technologies, because the reject is our product, which we want to have less color in that. Then there are a few other products. We have UF called G series. You have 1 kD, 2 kD, 3 kD product, which are polyether sulfone based. Okay, so not for textile wastewater treatment, but industries who are manufacturing dyes, when they want to enrich and concentrate the dye, they use our G series products. If they want to desalt the dye, suppose you have sodium chloride and dye, if you want to enrich the dye, concentrate the dye from 100 volumes to 10 volumes, these products are installed in the market mainly for the dye manufacturers. The applications such as dye concentration or dye desalting or purification. Then spiral, we all know we have spiral products, BW, SW, ROs based on TDS of the effluent to remove that. Then ozone, ozone is another product which we are trying to integrate in our this new flow sheet to remove the color. But it will also assist it will do disinfection of the water, and it will also remove partial COD. And finally, clarifier, we have a product called ActiFlow, much efficient clarifier for coagulation flocculation. Applications such as clarification when it comes to removal of turbidity, suspended solids, or could be hardness removal, desilication, silica removal kind of chemical treatment. This is efficient clarifier. It can be integrated based on requirement in primary, secondary, or tertiary treatment.
Hello, sir.
Yes, sir.
I would like to understand from you how keen it would be for you to set up an institute where people can learn the knowledge that you shared over here and use it in their day-to-day work.
Okay, that's a good question. See, I would say setting up an institute is another dimension, but we are setting up an experience center in our Hoskote Bangalore facility, and we have a technology center there. So where we would welcome, students or graduates or industry experts who wants to learn more about such technologies or our existing products.
Can we bring a DLI contingent team to your factory and on a visit?
Sure, why not? We'll have to discuss internally with our marketing and plant in charge, and we can surely have you to see our factory and the technology center. You're always welcome.
Thank you.
There's no red flag there.
Fine. We look forward. We'll catch up.
Sure,
with us. Thank you.
sure. Any more questions, please?
Sir, good afternoon. I've just come late to this seminar, but I read textile waste. So is it you were only talking about water or you're talking about other waste also?
No, we are talking of textile wastewater, dying
Water.
dying effluent textile wastewater.
Because this recycling of textile waste,
Yeah,
you know that.
yeah.
We actually shred is
Correct.
garments and then we create
Correct.
fabric.
Correct.
Not that.
No, we're talking of, sir. Yeah. We're talking of the pre-treatment and dyeing process when it generates huge amount of liquid wastewater.
Yeah.
And we're talking of converting that wastewater into a resource, sodium sulfate, recovering it at the economical process, along with recovering more than 98% of water.
Like a ZLD, no?
So, you're right. It's a ZLD, but it is de-sized ZLD. The reason is the value proposition of this patent stands here is we are not treating this effluent as a waste, but we are recovering 70 to 80% of this waste as a product. If you see the dyeing effluent with sodium sulfate or sodium chloride, they will compose of this component 78%. Yeah. So what we're doing is we are integrating, bundling the different technologies and products of Veolia in a flow sheet where we recover a product from this.
But there's still a 30% that goes out.
Yeah. The 30% that goes out, you're right, that goes to a conventional ZLD to recover the water.
So we need that ZLD.
Yeah, we need a ZLD, but we need at the half capacity. See, when you go for primary, secondary, and tertiary treatment, as you go to ZLD, we spend of around, 600, 800 to 1,000 rupees per cubic meter. Huge capital.
There's a norm, I don't know, sir, with a lot of buyers in Europe and the US, where they say ZLD has become mandatory. I think you know this.
Yeah.
They've now forced people. So I'm doing some projects where I'm forced to get into ZLD for this because, and then Envisol and all these companies are there,
Correct.
So this is a pre to ZLD. This is what you're saying. Yeah.
This is a pre to ZLD.
You're from Bangalore, is it?
Yeah, we're from Bangalore.
You Kannada matatra?
Sorry, no, I don't know Kannada.
You're Tamilian.
No, I don't know Kannada.
Okay, no problem, sir. We'll talk.
We'll talk. You please, you're welcome, sir, at our stall. Sandeep is right behind you. So what I'm trying to just give you last message is, you're right. We are de-sizing ZLD, sir. So what is happening is, today suppose you are sending all your effluent to a conventional treatment plant in ZLD. In this case, technology, you will be sizing your evaporator at half or 2.5.
No, that's a big cost reduction. I agree. But the ultimate thing is you still need a ZLD. That's what
you still need a ZLD.
Yeah.
But if I'm not brought it up here but the another angle there is if you have a lean effluent, okay, there's another angle.
Yeah.
We need to work on economics. Where people are using less water, they'll end up at, say, for the Bangladesh case. Okay, the TDS is 1,500, 2,000.
Yes.
Now, if I recover a product, and if I remove the color and organics, if I meet the discharge norms, you still don't need a ZLD.
Okay. So we'll be in touch, sir. Once you finish it, and thank you.